Hi dear students, today we'll be talking about solving two equations in two variables. One is a first degree equation and the other one is a second degree equation. Let's now remember together what is a first degree equation and what is a second degree equation. As you can see here, 2x minus y equals 3. Yes, it's an equation of the first degree where it has two variables, x and y. But x squared plus y equals 5 is a second degree equation that has two variables, x and y. Another example of a second degree equation is xy, and the two variables are x and y. Let's start with the warm-up and check it together. If x plus y equals 10 and x squared minus y squared equals 40, how can we find x minus y? If you remember the factorization, x squared minus y squared can be factored by difference of two squares, so it's x minus y times x plus y. As you can see here, that x minus y equals 40 divided by 10, which is 40. Let us do it with more details. You will see that x squared minus y squared equals x plus y times x minus y. And it's given to us that x squared minus y squared equals 40. And the x plus y equal 10. So to find x minus y, we need to divide the 40 by 10. So x minus y equals 4 as mentioned. Let's go and check the first example. In the first example, the question is asking you to find algebraically the solution set in R of the two equations x minus 2 and xy equals 5. Yes, I know that you can do it logically, that x minus y equal 2, two numbers, their difference is 2, where x times y equal 15, so two numbers, their product is 15. Yes, what two numbers minus each other is 2 and times each other is 15. Yes, good job, it's the 5 and the 3. But we must show our working out in steps. So let's do and check the steps together. So we'll work on this equation by moving the y to this side. So x equals 2 plus y. And then we're going to substitute this value of y, and then we're going to substitute this value of x in the other equation. So 2 plus y times y equal 15. By distributive property, you will see that y squared plus 2y equal 15. Put this 15 inside, y squared plus 2y minus 15 equals 0. In this case, let's factorize. Y plus 5 and y minus 3 equals 0. Then y has two values, either the negative 5 or the 3. So this part we did not take care of, that y may have a negative value. That's why showing the working out will help you a lot to get the correct answer. After you get the value of y, you need to find the value of x for each one of these two y values. X equals 2 plus negative 5, so x equals negative 3, and here x equals 2 plus 3, x equals 5. So the two values of x and y, it's either x equals negative 3 or y equals negative 5, or x equals 5 and y equals 3. So here we have two solution sets. either -3 and -5 or 5 and 3. In example 2, the question is asking us to find algebraically the solution set in R of the two equations x plus y equals 6 and x squared minus xy equals 8. As we did in the previous example, the first degree equation, I will go and make it as x equals or y equals. So we can move this x to the other side and make it as y equal 6 minus x. Then we'll do what? Yes, we're going to substitute it in the other equation. So it will be x squared minus x times 6 minus x equal 8. If I expand, so x squared minus 6x plus x squared. Yes, it's going to be a quadratic equation. Good job. So if you simplify it, it's 2x squared minus 6x minus 8 equals 0. Simplify it more, divide it all by 2, so x squared minus 3x minus 4 equals 0. If you factorize it, it's x minus 4 times x plus 1. So x would be here having two values. It's either 4 or -1. As long as x would be having two values, then y would be having two values as well. So if you substitute this value of x equals 4 in y, so y equals 6 minus x, which is 4, so y equals 2. So the solution set is x4, where y is 2. And here, if you substitute in y, y equals 6 minus -1. So y equals 7. So the solution set is -1 for x and 7 for y. So the solution set in here is 4 and 2 and -1 and 7. Let's move on to example 3, a different idea with the same system. Find algebraically the solution set in R of the two equations. The first one is y plus 2x plus 1 equals 0, or the second one is 4x squared plus y squared minus 3xy equal 1. In this case, we need to make one of them as x equals or y equals in the linear equation. So what we're going to do is, yes, good job, we're going to move the 2x and the 1. So y equals -2x minus 1. Going to the other equation, substituting each y by -2x minus 1. So 4x squared plus, instead of y, -2x minus 1 all squared minus 3x times -2x minus 1 equal 1. So it's 4x squared plus, how to expand the binomial squared, it's 4x squared plus 4x plus 1 plus 6x squared plus 3x minus 1 equals 0. To simplify it more, it's 14x squared plus 7x equals 0, because here the positive 1 and the negative 1 would be crossed out together. Then we're going to divide them all by 7. So it's 2x squared plus x equal 1. Take x as a common factor. So 2x plus 1 equals 0. So in this case, x equals 0 or x equal negative half. For each value of x, I will get its value of y. So x equals negative 2 times 0 minus 1, which is negative 1. So the solution set is 0 for x and negative 1 for y. Where in the other value of x, y equal negative 2 times negative half minus 1. So y equal 1. So the solution set for this one, negative half and 1. Let's move to another example, which is example 4. A rectangle of perimeter 14 centimeters and area 12 centimeters squared. Find its two dimensions. What's the rule of the perimeter? Good job. So the perimeter is 2L plus 2W. So 2L plus 2W equal 14. If I divide it by 2, so L plus W is automatically equal 7. And the length by width for the area, the length by width equals 12. So here we're going to change the W by moving the L here. So W equals 7 minus L. L times 7 minus L equal 12. So 7L minus L squared equal 12. Then to write it in a quadratic formula, so L squared minus 7L plus 12 equals 0. So if you factorize, L minus 4 and L minus 3 equals 0. So the L has two values, which are 4 and 3. If you substitute in W, you will see that W equals 7 minus 4, which is 3, and W equals 7 minus 3, which is 4. So the dimensions are, the length is 4 and the width is 3. Let's move to our last exercise. In this exercise, the question is asking you to choose the correct answer from the given answers. Let's start with the first one. The solution set of the two equations x minus y equals 0 and x times y equal 9. What is the solution set? X minus y equals 0, so two numbers, if you subtract them, will give you 0. So for sure the two values must be the same. Okay, but their product, x times y equal 9. So for sure it's not 0 and 0. And what two numbers multiply each other equal 9 and they are the same? So don't choose negative 3 and negative 3 only, and don't choose the 3 and 3 only. Yes, good job. The answer is both negative 3 and negative 3 and 3 and 3. Let's move to number 2. One of the solutions for the two equations x minus y equal 2 and x squared plus y squared equals 20 is, yes, you're going to do it by the same steps that we're doing, that we make x equals 2 plus y, and then you substitute, or you can do it logically. How can you do it logically? X minus y equal 2. The difference of two numbers is 2, where x is the bigger number because the result is positive. So automatically, choice number A is not a correct choice. Let's go and check choices B, C, and D. Two numbers, x minus y equal 2. So 2 minus negative 4 is not 2. 3 minus 1, yes, it can be 2, and 4 minus 2, it can be 2. Let's go and substitute in the second equation. X squared plus y squared equals 20. So for sure, the answer is, yes, good job, it's choice D. Last question. If the sum of two positive numbers is 7 and their product is 12, then the two numbers are, which of these choices their sum is 7? 2 and 5, yes. 2 and 6, definitely no. 3 and 5, maybe. 1 and 6, maybe. But which one from A, C, or D, their product is 12? Yes, excellent. Choice for sure is choice C. By finishing this example, we came to the end of our session. Thank you very much and take care.